In today's lesson, we're going to start with a new function called a logarithmic function. You may have heard or seen the word log before on your calculator or in textbooks. I may have not really understood what that meant. But we're going to talk about logarithmic expressions in their relationship to exponential functions. Log functions and exponential functions are actually inverses of each other, and we're going to kind of point that out in just a second. But first, let's just kind of look at how they compare and how we would write them. If you look at our definition of a log, we're going to actually define the log with a base of b. So if I write a log function, it has a base of b. So I'm going to say log base by equals to x. So it has a base of b. So what I want to show you is, if you recall from exponential functions also had a base. And of course, if we had a base, it was always raised to the x power, and we were saying that that was equal to y. Now, we were probably seeing it in this form more often than not, but these mean the same thing. The connection here between these two is actually the base. So we need to be aware of that relationship between exponential functions and log functions, that they have the same base unit. Now, if you look at this, you can kind of start to see a little bit of a relationship between the b, the x, and the y. And the first thing that we need to get comfortable with is just simply rewriting from an exponential function to a log function, and from a log function to an exponential function. So I'm going to just give you a little short trick to remember how to do this. If we start with a log function, we always want to start with the base, and we're going to take the base and we're going to raise it to the power over here that the log function is equal to. And then, of course, if we're rewriting as an exponential, when we raise it to that power, then it's going to be equal to what the log had in the other form. So this is just a little shortcut. It's kind of like a little circle here to help you realize that if we take b and we raise it to the x power, then that would equal back to y. So just a little shortcut on how to write log form to exponential form. Now, we give you a couple examples down here, just basic rewriting in general. Now, before we do that, we want to take a look at a couple examples here of what we're talking about with them being inverses. If you recall from previous sections, we talked about inverses. Let's just look at a couple problems here. If we had y equaled 2 to the x power, and then we had y equaled log base 2 to the x, and of course you could go through the rewriting portion of that and see that these two are related to each other. Excuse me. What we're going to do is we're going to show you how that looks on the calculator. So if I take the calculator and I graph these ahead of time so that you can see them, you'll recognize the exponential function, 2 to the x power. So we've been dealing with exponential functions, and in this case this is an exponential growth function. And you can see the second one is the reflection of that, and if you recall, inverses are reflected over the axis of y equals to x. That is the reflection line for inverses, and I can just graph that very quickly. And you can see that particular reflection, and so you can see one graph reflecting over the other one across that line, and you can see that the exponential function and the log function are actually inverses of each other. Now, if we were dealing with an exponential decay function, these would actually intersect and not across each other, but they would still be mirror images. And we may dive into that a little deeper later in future classes, but I just wanted to kind of give you a visual of the inverse. Now, in this particular section, we're going to keep it real simple. We're just going to focus on base units and rewriting exponents and logs to represent each other. This may seem simple and straightforward to begin with, but it's extremely important that you understand how to do this rewriting process, because it's going to help you out later on when we actually have to start solving exponential functions, and we have to start solving log functions, since they're written in the form of equation many times. So let's just take a look at a couple rewrites. If you followed that path of just kind of circling around, you could see that the 2 would be raised to the 5th power, and of course that would be equal to 32. And of course we know that from our little set of tables that we've been working with, learning that 2 to the 5th equals to 32. So this is a good example of that. Now we have 4 different rewrites here just to get some practice on, but 2 of them that we want to bring your attention to very quickly is B and C. And if you look at B and C, we have log base 5 1 equals 0. And that would make sense since 5 to the 0 power equals to 1. So that's a special log value that you'll want to be particularly used to. And then C is log base 10 10. So if the base and the unit are the same, then that is going to equal to 1. Which also makes sense because 10 to the 1st power equals to 10. So these are 2 special log values that you will want to keep an eye on. Now, let's think about this, and let's go back to part A, and let's think about this from another standpoint. Log base 2, 32, can also be written as this. And of course we can know it's going to equal to 5, but I'm going to actually come back to that in a second. 32, if we know from previous units, is the same thing as saying 2 to the 5th power. So here we have a log with an exponent in it. But if we look simply at our new rules here that we've kind of somewhat developed, we know that this log 2 is equal to 1. So if that is the case, then what we've got left here is simply 5. So we've shown just a simple reduction or simplification of log 2 32 as being 5, and then of course that's what we had previously. Log base 2 of 32 equals to 5. So you can see through the simplification process and using this log rule that we have here, log b of b equals to 1, we could use that property to simplify logs. Now, we're fortunate that we won't have to do this in all cases because we have a calculator that helps us out. And we can use that calculator to actually come up with a direct answer. But you do need to be aware of how the properties are used. So, simply speaking, to start off, we just want to kind of work with logs and figure out how to rewrite them in exponential form. So we'll start off with sample problem 1. And you use that little circular technique if that helps you. And we just want you to simply pause the video at this point and rewrite the 2 logs as exponents. Okay, so if we take this first one, we can see simply that we take the base, so 3 is our base, and of course in an exponent we have a base raised to a power, so I'm going to take this base and I'm going to raise it to the 2nd power. So 3 is going to become the base of my exponent. I'm going to raise it to the 2nd power, and of course we know that 3 raised to the 2nd power is going to be equal to 9. And so you can see that we had the log form at the beginning, and now we have the exponential form second. Same thing with part B. 8 is going to be our base, and if we raise 8 to the 0 power, we know anything raised to the 0 power is simply equal to 1. So this is just a simple way for us to rewrite logs. Now, if I wanted to look at the rules that we used up above, we could simply do this. Log 3 of 9 equals to 2. Well, we know that 9 is the same thing as 3 squared. And then, of course, log 3 of 3 is just simply 1. So 1 to, that leaves us 2 equals to 2, which does check out. So this is some very simple, straightforward uses of logarithm properties and rewriting logs and exponents. So let's take a look at the next sample problem. Now, let's think about this. It says to evaluate the expression on the calculator. What I want to do before we simply evaluate this expression on the calculator is to put this in the form of an equation that you would have to solve so that you could see how convenient logs are. Let me take part A and I'm going to rewrite this. I'm going to say, let's solve this expression. 4 to the x equals 64. Well, at this point, we would be doing a lot of guessing and checking to find out what x is equal to. It would take us a little bit of time and a little bit of doing to figure that out. Now, fortunately, you've spent some time learning your cubes and your fourths and your fifth roots and powers, so your guessing and checking would probably not take as long as it would with, say, some higher numbers. But simply speaking, if we actually rewrote this as a log, in essence what we have is this. Log 464 is equal to x. And then we can use our calculator to figure out what x is equal to. So I'm going to go to my calculator and let's go back to the calculator part and let's see how we're going to do this. If you look here to the left of the keyboard, you have a 10 to the x button, and then right above that is the control function log. So I'm going to hit control and then at 10 to the x, and that gives me a log, and you see it gives me 2 spots. And if you go back to the notes, you can see we have a base of 4 and then 64. So we have 4, and then we're going to tab over, and then we're going to hit 64. If we simply hit enter, it gives us our answer of 3. So we know log base 464 is equal to 3. Now, this wasn't an equation. We weren't trying to solve it. We were just trying to simplify this or get the value of it, so we evaluated it. But it gives you a good picture of how we would use logarithms as a way to solve exponential functions instead of guessing and checking. So if we look at this one, now here you could see that we had 4, the base was smaller than the unit, so we knew we should know that the answer, the evaluation, is going to be a whole number. Here, however, if we had this as x, that's the same thing as 32 to the x power equals 2. So we know that this value of x as an exponent is going to have to actually be a smaller value or a smaller number. And the case here is simply that you can quickly identify what your answer should look like just by seeing the relationship between the base and the unit and the log. So if we go back here, we can use our log function again. And this time we're doing 32. Oops, sorry about that. Try that again. So 32, and then I'm going to tab over, and then that's going to be 2, and that gives me 1/5. Now, your calculator may have given you something like this. You may have gotten 0.2, and of course, if you need to give your answer in terms of a fraction, you can actually change that decimal to a fraction by going to the menu, and you can go to the number part, and you can say approximate to a fraction and hit enter, and then of course it's going to take that and make it 1/5. So the calculator actually can convert your decimals and fractions very quickly if you want to do that as well. So in this particular part of the notes, we could either say that this is 1/5 or 0.2, depending on how we want the answer to look. So there's a quick view of your calculator. Now, base numbers and base units are all based off of counting systems. Our counting system is based off of the number 10, and if you think about that very quickly, you learn how to count. You learn how to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you really kind of start over with 11. That's just tens with a 1, and then 12, 13, that's just going back through the tens again, and then when you get to 20, another 10, you start over with the ones and work your way up to the next 10. So our counting system actually has a base unit of 10. So logs with a base unit of 10 are actually called the common log because that's based off of our counting system. So what you'll see a lot of times is instead of writing the base unit 10, it'll simply be missing. So instead of writing the base of 10, we'll just simply write it without. Now, fortunately, your calculator recognizes this. So we see in sample problem 3, it asks us to evaluate the expression on our calculator. Well, we know that this is the same thing as log base 10 of 5. And so if we decided to put that into our calculator, we would have log base 10 of 5, which is going to give us, apologize, I'm going to have to put the decimal point in it. You probably did not. Yours probably did that for you. And I'm going to have to put a decimal in here to get a non-exact answer. And so then we see we have an answer that looks like this, 0.69897. So if we're looking at that, however, if I want to put this in here and I know it's log base 10, I can actually skip the base part and simply put in a 5 and hit enter, and notice that it fills in the base 10 for me. Now, you probably don't have a lot of experience of working with counting systems other than a base of 10, but if you have any kind of computer education at all, you know that the computer system works on bits and bytes, and that the computer is built off of a binary system of zeros and ones. And so all the different patterns of zeros and ones possible is what your computer language is actually written off of. So everything that you do here on the computer, on your iPhone, GPS, any kind of technology that you're dealing with is based off of mathematical principle of a number system that has a base 2. So we're talking base 2 for bits and bytes. So you can have any kind of combinations of zeros and ones and zeros and ones, and that's a base 2 system. Whereas our counting system is base 10, as we discussed previously. So go ahead and let's try to evaluate log base 10 7, or the common log there, and you just punch that straight into your calculator. And you can tab right by the base and go straight in there, and I'm going to hit the decimal point to make sure that I get the full decimal, and of course in this case that's 0.845098, or if we wanted you to round off to the decimal, we would tell you what to round off to. So you needed to get a couple of things out of this quick simple lesson. First and foremost, understanding the relationship between exponential functions and log functions. They're inverses of each other. How to rewrite from a log function to an exponential function and vice versa. And how to simply use your calculator to come up with the value of simple logs. And that's pretty much it. If you have that as a good basis, that'll be a good springboard to other lessons that we will do using logs in the upcoming sections.